In the name of God. I am Maryam Khosravi, and together with the team member of Dr. Ahmadreza Montazerolghaem, Dr. Mohammad Reza Khayyambashi, and Fatemeh Rezaee will present the article by title An Optimal Workflow Scheduling Method in Cloud Computing Using Three-Objective Harris-Hawkes Algorithm at the ICCKE 2022 conference. At first, I will present abstract and introduction, then related work, system model, purpose, method, evaluation, and finally conclusion. Today, the Internet of Things used to collect data by sensors and store and process them. As the IoT has limited processing and computing power, we are turning to integration of cloud and IoT. Cloud computing process large data at high speed, but sending this large data requires a lot of bandwidth. Therefore, we use fog computing, which is close to IoT devices. In this case, the delay is reduced. Boost cloud and fog computing are used to increasing performance of IoT. Job scheduling of IoT workflow request based on cloud fog computing plays a key role in responding to this request. Job scheduling in order to reduce make span time is very important in real-time system. Also, one way to improve system performance is to reduce energy consumption. In this article, three-objective Harris-Hawkes optimizer or HHO scheduling algorithm is proposed in order to reduce make span time, energy consumption, and increase reliability. Also, dynamic voltage frequency scaling has been used to reduce energy consumption, which reduced the frequency of the processor. Then HHO is compared with other algorithms such as wall optimization algorithm, firefly algorithm, and particle swarm optimization, and purpose algorithm shows better performance on experimental data. The purpose method has achieved an average reliability of 83%, energy consumption of 14.95 kilojoule, and make a span of 272.5 seconds. The concept of IoT was first presented by Kevin Ashton in 1999. Purpose of IoT is to collect environmental data through sensors and store and process them automatically. IoT suffers from problems such as performance, security, privacy, and reliability due to processing and storage power. And therefore, to solve these problems, we move towards cloud computing. Cloud computing processes a huge amount of data quickly and cheaply. To send this large data to the cloud, a lot of bandwidth is needed, and fog computing is used to solve this problem. To reduce latency and network traffic volume in the cloud, data is temporarily processed and stored on network edge devices. Fog computing has many advantages, including geographical distribution and large scale, lower operational cost, and flexibility and heterogeneity, and scalability, low latency. In Figure 1, cloud computing is first substrate where cloud servers store and process large volumes of data. In next substrate, there is fog computing, which consists of fog machines. The bottom substrate contains the end devices of the IoT. Fog computing is a mediation between terminal devices and the cloud, and it brings several services near to the terminal devices. Each fog server is a virtual machine to manage fog virtual resources. We use fog scheduling, which in addition to providing quality of service, minimize make span, resource consumption, and data transfer. Job scheduling, in order to reduce make span time, is very important in a real-time system. Also, reducing the energy consumption improves system performance. Therefore, in this contribution, an optimal workflow scheduling method is presented using three objective HHO algorithms. In this schedule, we considered factors of make span time, reliability, and energy consumption. Part 2, related work. In 9-article hybrid optimization algorithm called AEOSSA in closed fog environment. In 10, genetic algorithm was used to minimize overall latency to schedule IoT jobs. In 11, optimal task uploading strategy for delay-sensitive and resource-sensitive programs. In 12, enhanced version of multiverse optimizer EMVO algorithm present for scheduling jobs. In 13, optimization model using mixed integer programming for minimizing deadline misses. And in 14, hybrid deep Q-learning task scheduling or DQTS algorithm combining Q-learning and artificial neural network algorithm present for scheduling jobs. None of the previous works have investigated the three parameters of make span time, reliability, and energy consumption at the same time. In part 3, system model. Cloud fog architecture has three substrate, edge, fog, and cloud substrate. In this part, the formulation of the problem for job scheduling in cloud fog is described. The cloud fog system consists of a set of heterogeneous virtual machines denoted by VM equal V1, V2, V3 to VM. Each V is a physical processor that works in various frequency levels and voltage, and is determined SBC supply voltage, maximum processor processing capacity, and frequency level. And the workflow is a set of jobs denoted by W and modeled by a directed cyclic graph or DAG. This is shown in figure 2. Each job is allocated to a VM with a special frequency. The execution time of a job Ji allocated to VRFY is represented by one equation. DVFS is a mechanism that decreases energy consumption by reducing the CPU frequency level of a VM and uses a powerful management technique to decrease energy consumption and high reliability. It uses a powerful management technique to decrease energy consumption and high reliability. Part 4, purpose method based on Harris-Hawkes optimization. HHO is a population-based meta-heuristic algorithm. Meta-heuristic algorithms mimic natural phenomena and include two phases: exploration and exploitation. We use three objective HHO for scheduled jobs to minimizing make span and energy consumption and increasing reliability. We calculate fitness by equation 2 and make span by equation 3. We used HHO rules and formulas to calculate the best and optimal answer, that is job scheduling. And part 5, evaluation. In this article, two workflow datasets, including montage and Lego, with size of 25, 50, 100, 1000 jobs kilobyte taken from 29 are used as the tested dataset. Also, we use MATLAB 2018B on Windows 64-bit and 5-core system. From the criteria of fitness function, reliability, make span time, and energy consumption to evaluate HHO and compare it with FAPSO and WOA has been used. In Table 1, fitness function value obtained by the algorithm for the two datasets used in this article is shown. In this article, for PSO, FAHHO, and WOA algorithm are compared under the same conditions. The four related algorithms obtain the optimization process to solve problems by using two phases of exploration and exploitation. Therefore, according to difference in a structure of algorithms, output of each algorithm is definitely different from other algorithms. According to Table 1, HHO obtained a lower value of fitness function than other algorithms. Table 2 shows reliability value. HHO is higher than other three algorithms. Figure 3 displays a reliability graph for montage dataset, and Figure 4 displays a reliability graph for a LIGO dataset from Table 2. According to obtained result, HHO has an average reliability of 83%. Table 3 shows the amount of energy used to execute different workflows by different algorithms. HHO consumed the least amount of energy. Figure 5 shows energy consumption graph from Table 3 for the montage dataset, and in Figure 6 energy consumption graph for LIGO dataset. According to obtained result, HHO has an average energy consumption of 14.95 kJ. Table 4 shows make span time value obtained by a different algorithm for two different datasets. Figure 7 shows the make span time plot from Table 4 for the montage dataset. The results show HHO has an average make span time of 272.5 seconds. And Figure 8 shows a make span time plot from Table 4 for LIGO dataset. Finally, Part 6 conclusion. In this article, the optimization algorithm of Harris-Hux was used as an optimization algorithm to optimize the workflow scheduling problem in cloud fog environments. The three criteria of energy consumption, reliability, and make span time were used as main criteria to determine fitness function, and the final fitness function was obtained from a combination of these three criteria. Finally, Harris-Hux algorithm was able to determine the best and most optimal virtual machines for workflows by using the minimization of fitness function, so that the lowest energy consumption, highest reliability, and the lowest amount of wake span time are compared to Firefly and Wall algorithm, and obtain a swarm of particles. You can see the references. Thanks for your attention.